Okay, so we've talked a lot about angles in circles. So now we're going to switch and talk about segments in circles. And there's three basic types that we need to worry about. Three cases. So let's take a look at the first case. And that's called the chord-chord case. And that's when you have two chords that cross in a circle. And notice if two chords cross in a circle, they split each other up into four segments. And it turns out that if you multiply, in this case, A times B, that will equal C times D. So in terms of what we're looking at, that means whenever you have two chords crossing, this piece times this piece will equal this piece times that piece. Second type is called a secant-secant case, and that's when you have two secants. Secants are segments that cut through a circle and hit it in 2 points. And so it's a little more complicated, but it's the same idea. We're multiplying two things, and that's going to equal the product of two other things. So I have these in two separate colors. So look at the green secant, and the outside piece has length A, and the whole thing would have length A plus B. So we're going to multiply the outside piece, which is A, times the whole thing, which is A plus B. And that's going to equal the same idea with the other chord, or the other secant. The outside piece is C, and the whole secant would be C plus D. So C times C plus D. So I think it really helps to remember the phrase for this one. I say the outside piece times the whole thing, or the whole segment, the whole secant, equals, and then outside piece times the whole thing. So I'll just use some quotes instead of writing that all again. So the outside piece times the whole thing equals the outside piece times the whole thing. And then the third case, the last case, is a secant tangent. So I've already explained what a secant is. The green segment is a secant. A tangent is a segment that just touches the circle at one point. It just hits the circle at one point. It turns out, by the way, that the point where that tangent hits the circle, if we draw a radius from the center to that point, the radius is going to be perpendicular to the tangent. And so that's really useful in solving some problems with circles. But for now, we're not going to worry about that. And we're just going to focus on the lengths of the green and the blue segment. So the nice thing about this is even though the picture looks a little bit different, it's the same idea as the secant-secant. So it's the outside piece, and for the green that would be A, times the whole thing, which would be A plus B, is equal to the outside piece for the blue, which is C, times the whole thing for the blue, which is also C. So we can still think of it as the outside piece times the whole thing equals the outside piece times the whole thing. All right, so let's work through some examples of each of these so you get the hang of it. So the first one here is we have to figure out the length of the segment that's referred to as X. So I'm going to write this out a little bit more than you normally would, just so you get the hang of it. So I'm going to draw a segment CE in green and ED in blue. So CE times E to D is going to equal, and then let's use, we've already used red, green, so how about we use purple. So B to E in purple times, and I guess we'll use, how about yellow? E to A in yellow. Now the order doesn't really matter on how we do this. Just make sure that you're using the two pieces from segment CD on one side and the two pieces from segment AB on the other. So CE, so we have 6 times 4 equals b to e, which is x, times e to a, which is 8. So we got 24 equals 8x, so x is equal to 3. And that's it. That's how easy it is. Let's try one more example of this type, the chord example. Solve for x. Now you might want to hit pause, work it out, and then hit play again and see if you got the right answer. Okay, so we're going to do, and you can do it either way. You could say 9 times 4 or 4 times 9, and you could say x times 6 or 6 times x. Doesn't matter. I'll start with the one that has x. So I'm going to say 6 times x is going to equal 9 times 4. So we have 6x equals 36. And if I divide by 6, I get x equals 6. And that's it. Alright, let's look at the secant example. Now this takes a little more practice, but it's still not terribly difficult. It depends on where the missing piece is at though. Alright, so let's start with segment secant A to C. Alright, let's say the outside piece, which is 4, times the whole thing, which is 4 plus 6. I'll write 4 plus 6. You can just write 10 if you want. Equals, and now we'll go to the other one, the other secant from A to E, and that's going to be the outside piece, which is 5, times the whole thing, which would be 5 plus x. The biggest mistake students make on these problems is they would say 4 times 6 equals 5 times x, and that's wrong. You're not going to get the correct answer if you do it that way. So you have to remember to add the two pieces for the whole thing. Alright, so what we have here is 4 times 10. Now on this side, we're going to have to distribute. So I'm going to multiply 5 times 5 is 25, and then 5 times x is 5x. And now I have to solve this algebraic equation. So 4 times 10 is 40. So I'm going to subtract 25 from both sides, and I'll get 15 equals 5x. And then divide by 5, and we get x is equal to 3. Solve for x, we're done. Now, the more difficult type of problem that happens with the secant is if the missing piece is on the outside. So I'll show you what I mean by this. So I'll start with the green piece. The outside is y times the whole thing would be y plus 2. And that should equal the outside piece, which is 4, times the whole thing, which is 4 plus 8, or 12. Now if I distribute, y times y is y squared, and y times 2 is 2y, and then 4 times 12 is 48. So we have a quadratic equation to solve here. We've only done a couple of these throughout the year, and there's none of, the homework doesn't have any quadratics to solve, so that's okay. But it's a good idea just to see this, because you'll see this again next year in Algebra 2. So when you have a quadratic, you want to move everything over to one side and set it equal to 0. So I'm going to subtract 48 from both sides so that it equals 0. Now there's a quadratic formula which you learn in Algebra 1, hopefully. There's a shortcut, and sometimes it works, and that's factoring. And so in this case, it turns out we can factor. Quadratic formula always works. Factoring sometimes works. And so I'm going to have two binomials. I'm looking for two numbers that multiply to negative 48, and they add to positive 2. Well, that's going to be an 8 and a 6. And if the 8 is positive and the 6 is negative, if I distribute, or FOIL, I'll get y squared plus 8y minus 6y, and those are like terms, which will give me 2y, and then minus 48. So that means that either y plus 8 is going to equal 0, or y minus 6 is going to equal 0. If y plus 8 is 0, that would mean y is negative 8. But wait a minute, y represents the length of a segment, so that's impossible in this example. And if y minus 6 equals 0, that means y is equal to 6. So there's your solution. So like I said, don't freak out too much if you're having trouble following this. There's no homework problems like this one, but I just wanted to show you that sometimes that comes up. Most of the time though, when you have secant, the easier examples will look more like example 3. Alright, so that takes us to the last example, and that was the secant tangent. And it's basically the same idea. So I'll start with this secant here from P to R. So the outside piece is 3 times the whole thing, which is going to be 3 plus 9, or 12. And that's going to equal, now for the tangent segment, the outside piece is just x, and the whole thing is also x. So we get x times x, or x squared. So 3 times 12 is 36, x times x is x squared. We remember how to do these. We take the square root of both. And so we get the absolute value of x is equal to 6, which means x could be positive or negative 6. But since we're dealing with the length of a segment, x can't be negative, so we take the positive answer, x equals 6. And there you go. So now you're ready to handle problems that are either chord-chord, secant-secant, or secant-tangent. So the assignment is worksheet 6.